Hi everyone, thank you for joining us today. In this presentation, we will be exploring about PVT demonstration, switching essentials. Before we start, we would like to introduce myself and my team members. My name is Nita Ramsali and Mrs. Sabur Hamida, Binti Muhammad Yusuf and Shalini Arvind Prasad. Here I would like to list down those tasks we did in this PVT demonstration, which is topology, task 1 VLAN configuration, the multi-layer switch represents as SWA, SWB and SWC. Task 2 assign VLAN to interfaces. Task 3 configure trunking and port channel. Task 4 inter-VLAN routing. Task 5 testing and verification, and IP address configuration between PCs, and then lastly is ping process between PCs that is connected between the multi-layer switch. Okay, the given task scenario is you are working as a network administrator at the XYZ company. The company's network has 3 pieces of multi-layer switches connected together. You need to design the network topology inside the packet tracer simulation software. You are required to create 2 different VLANs for each multi-layer switch and make sure the VLANs can be communicate successfully with each other. You are freely having permission to use any VLAN ID and VLAN's name depends on your own choice and creativity. The connection among the 3 multi-layer switches must be configured as 3 different port channels, and you are permitted to choose in applying any link aggregation protocol. Network administrator must select only one multi-layer switch to handle inter-VLAN routing in the network. In addition, you need to compile all the configuration commands and procedures that you have just followed and completed for the given task in a form of proper report writing. The note given is needed to be mastered in the concept of inter-VLAN routing and also the concept of link aggregation. Okay, so this is the network topology created in Cisco Packet Tracer. Features a structured design for an organization utilizing 3 multi-layer switches labeled as SWA, SWB and SWC, which are interconnected in triangular setup. Each switch is connected to 2 PCs and the switches form a network for where VLAN segmentation and inter-VLAN routing are implemented to organize and control network traffic. Each multi-layer switch is configured to handle specific VLANs as indicated by the color pattern, which is green for SWA, blue for SWB, and pink for SWC. This segmentation divides the network into distinct areas, allowing each department or group of users to open using its own VLAN. VLAN segmentation enhances both security and efficiency by isolating network traffic. Devices within a VLAN can communicate with each other seamlessly, while inter-VLAN communication is selectively enabled, ensuring that only necessary data flows across VLAN boundaries. The dotted black line between the switches represent trunk links configured to carry traffic for multiple VLANs across each connection. These trunk links are also configured as port channels using inter-channel, which combines multiple physical links into one logical link. This configuration increases bandwidth between switches and adds redundancy. If one link fails, other within the connecting. By aggregating links in this way, the network can handle higher data volumes and provide more reliable connection between switches. In this setup, SWA likely serves as the primary switch for the inter-VLAN routing. As a multi-layer switch, it can route traffic between different VLANs, enabling communication across departments or network zones as needed. Alright, and then this inter-VLAN routing setup is essential for segmented network where devices in certain VLANs sometimes require access to share resources. Overall, this topology demonstrates a robust network design that provides scalability, security, performance, and reliability. VLAN segmentation supports organized secure communication across departments, while port channels aggregation improves bandwidth and redundancy. This design ideal for an organization seeking efficient network management with high levels of control over traffic and resource access. Okay, next. Task 1. VLAN configuration. SWA, SWB and SWC. This image displays the VLAN configuration for 3 multi-layer switches, which is SWA, SWB and SWC in a network setup. Each switch is configured with two unique VLANs, each assigned a distinct VLAN ID and named to logically separate network traffic, which is SWA has VLAN 10 named sales and VLAN 20 named marketing. And then SWB includes VLAN 30 for HR and VLAN 40 for IT. And then SWC contains VLAN 50 labeled as finance and VLAN 60 for operations. This VLAN configuration ensures that each department has its dedicated network, enhancing security and traffic management within the network. Defining VLANs in this way also simplifies the management of communication within departments and controls access between them as needed. Okay, the next is task 2. Assign VLANs to interfaces SWA, SWB and SWC. Those images demonstrate the process of assigning specific VLANs to switches on 3 multi-layer switches, which is SWA, SWB and SWC. Each switch configuration involves setting up an interface range to place designated ports into access mode and assigning them to a particular VLAN. SWA assigns ports to VLAN 10, ensuring that connected devices are part of the sales VLAN. And then SWB assigns ports to VLAN 30, connecting devices in the HR VLAN. SWC configures ports for VLAN 50, which group devices under the finance VLAN. These configurations are essential for segmenting the network into logical groups, thereby enhancing security and controlling traffic between departments. That's all from me. The next slide will be conducted by Sabah Hamida.
Hello, hi semua. I'm Sabah. Okay, task 3. Task 3 configuration traffic and port channel. In this configuration, we are setting up line link aggregation between 3 switches SWA, SWB which allow us to combine multiple physical links into a single logical link. This approach increases bandwidth and provide redundancies, enhancing both performance and reliability in the network. First, on each switch, we enter the configuration mode for the specified range of interface. In this case, gigabit Ethernet ports 1/0/3/4. By assigning this port to the same port channel 1, using the channel group command in mode active, we enable link aggregation control protocol (LACP), which dynamically negotiates and manages link aggregation. Once the port channel interface is created, we exit the interface configuration range mode and switch to the newly created logical interface, port channel 1. Here, the switch port mode trunk is applied, setting up the port channel interface to carry VLAN traffic between switches. Next, the same steps are repeated on each switch. This configuration ensures the traffic across this port channel will have redundancy. If one physically link fails, the remaining link can maintain the connection. Additionally, the trunk mode allows the switch to carry multiple VLANs across the aggregated link, supporting more flexible and scalable network design. Okay, next. Task 4. Inter-VLAN routing. This configuration sets up inter-VLAN routing on 3 switches, SWA, SWB, and SWC, by creating VLAN interface by specifying IP address. For each VLAN, we enter the interface configuration mode, assign a new unique IP address to serve as a gateway for the VLAN, and then bring the interface up. On each switch, IP routing is enabled with the IP routing command, allowing the switch to route traffic between VLANs. This setup allows devices in different VLANs to communicate through the multi-layer switch, make it function like a router for efficient network segmentation and traffic management. Okay, this is Gen inter-VLAN routing method we use in SWC, SWA, and SWB. Okay, next slide is go to Sharmini.
Hi guys, I'm Sharmini Abdullah, and let's go to the task 5, testing and verification. First of all, go to the switch and click into the CLI. First of all, we have to use show VLAN brief to check VLAN assignment. So we have to type show VLAN brief. We will get the SWA list of the brief. Secondly, we have to insert IP interface brief. So we have to type IP interface brief. So we will get the SWA brief, IP interface brief. Lastly, in summary, we have to type inter-channel summary in CLI. So we will get the final summary of our inter-channel SWA. As soon as SWB will repeat, we have to type show VLAN brief. So we will get the history of our VLAN brief, and we have to type IP interface brief. We will get the IP interface of our SWB, and lastly we have to type show internal channel summary. So we will get the final inter-channel summary of our SWB. Same as SWC brief, SWC testing and verification. So same as in CLI, we have to type show VLAN brief. So we will get the FWC brief. So nextly we have to type IP interface brief. So we will get the IP interface brief of FWC. So lastly we have to show interchannel summary. So we will get the last interchannel summary of FWC. Nextly guys, we have to configure IP address configuration in PC. So in PC0, click into PC0. So go to the desktop, IP configuration, desktop. We have to insert IP address. At lastly, we have last number. We have to insert 1. Go to the PC2, same as desktop. Same as IP address configuration. Go to the desktop. Lastly, we have to insert number 1. We have to insert IP address. Last address is 1. In PC1, same as IP address configuration PC. In desktop, lastly we have to insert 2. In PC3, we have to insert IP address as same. And lastly, we have to insert number 2, and this all we have to configuration. And PC4, and PC4, click into PC4. We select IP address configuration, desktop, and lastly we have to insert number 1 in IP address. In PC5 also we have to insert IP address, but lastly we have to insert number 2. And this is the steps of configuration IP address. And nextly guys, we have to pin process between PC to PC. First of all, PC0 to PC1. First of all, go to PC0. We have to copy PC1's IP address. So we have to copy paste our PC1's IP address. So the result will become like this. After configuration, test connectivity by pinning across VLAN verified successfully inter VLAN routing. Okay. The same ping process between PC2 to PC3. So straight away go to the PC2. Before go to the PC2, we have to copy PC3's IP address. So PC3's IP address. So after that, we have to after the copy the PC3's IP address, go to the PC2. Copy paste PC3's IP address and enter. It will be show our IP. It will be show our command. Lastly and last one, ping process between PC4 to PC5. So we have to copy PC5's IP address. So go to the PC4, copy paste our PC5's IP address, click enter. So we will verify every PC's ping process. And that's all from me, and that's all from our group. Thank you guys.